In this video, we're going to be talking about the definition of vertical and horizontal asymptotes. So let's begin by first looking at a couple graphs. We're going to look at the graph of f of x equals 1 over x and g of x equals 1 over x squared. Now notice that here, in both cases, both of these graphs approach the y-axis, but they never actually touch the y-axis. This is what we call a vertical asymptote of the graphs of the functions. A vertical asymptote of the graph of the function is where it approaches infinity or negative infinity as x approaches that value from either side. So it doesn't have to just be the y-axis. It can be any number. Like in this case here, if we have the c value, we can see that this is a vertical asymptote because we see that our function gets really, really close, but it never actually crosses it or touches it. You can have a function with no vertical asymptotes. You could have one vertical asymptote. You could have many vertical asymptotes. To locate the vertical asymptote of a function, you have to determine the real numbers x where the denominator is 0, but the numerator is non-zero. So if we consider a rational function f that's defined by p of x divided by q of x, where p of x is its own equation and q of x is its own equation, so they come together to make a brand new equation, and they have no common factors other than the number 1. If c is a real 0 of q of x, then x equaling c is going to be a vertical asymptote of the graph because it can't ever get there. Let's visit what it means to be a horizontal asymptote. So we're going to come back and take a look at our graphs once more, specifically of our 1 over x and our 1 over x squared. So we were just looking at their vertical asymptotes with the y-axis, but now if we take a look at the x-axis right here, we see that each function is going to get really, really close. Let me change that. All right, so there's our x-axis, and now we can see our graphs a little bit better as they get closer and closer and closer, closer and closer in each instance. But they never actually touch or cross the x-axis. These are horizontal asymptotes. Let's come on back here. So by definition, the line y equals d is a horizontal asymptote of the graph of a function f if f of x approaches d as x approaches infinity or negative infinity. So here we see our asymptotes right here, these pink lines that I'm highlighting green. And as we look at the blue line right here, it gets really, really close, but it never crosses or touches. Now, while the graph of a function may not cross a vertical asymptote, it actually can cross a horizontal asymptote. Let me say that one more time because it's kind of a big deal. In fact, why don't we write it down? The graph of a function may cross the horizontal asymptote, which is different from the vertical asymptote. For our vertical asymptote, our function will never cross it. It will only ever approach it. But the graph of a function may cross the horizontal asymptote. So how do we identify a horizontal asymptote? Well, recall that the leading term determines the far left and the far right behavior of the graph of a polynomial function. And since a rational function is the ratio of two polynomials, it seems reasonable that the leading terms of the numerator and denominator determine the end behavior of a rational function. So we can take a look here. So if we let f be a rational function defined by this equation right here, and on the numerator, and this equation here in our denominator, then the definition of f of x indicates that n is the degree of the numerator and m is the degree of the denominator. So if the numerator is larger than our denominator, right? That's what it's saying. If it's larger than our denominator, then we can say that f is going to have no horizontal asymptotes. Okay, so if our numerator's degree is larger than our denominator's degree, then there will be no horizontal asymptote. But if our numerator's degree is smaller than our denominator's degree, then the line y equals 0, or the x-axis, is going to be the horizontal asymptote of f. And if the degrees are equal, then we can say that the line y equals a to the n divided by b to the n is the horizontal asymptote of f. Now notice that just means I'm taking the coefficients, those leading coefficients, and dividing them. And that becomes the line for my horizontal asymptote of f. And a rational function may have many vertical asymptotes, but it can either have 0 or 1 horizontal asymptote. That's it, 0 or 1. And so that is what a vertical and a horizontal asymptote are and how to identify them.